So let's begin today's video. In my previous video, I had explained like what is Python, what are its advantages, what are its domain applications where it can be used, just the basic things. And today we will understand a little bit more about the concepts. Like in my yesterday's video, I have used a lot of concepts related to Python or any basic programming language. But if you are new, then it might be confusing or you might not be aware. So let's start with those things first. Then we can go into exact details of Python, like coding and all such things. So yeah, let's move to the next slide. And so I have told you that Python is a high level language. So if someone is new, they might not understand what is a high level language. So basically high level language is a language which can be written in plain English, which is easily understandable. So writing the code in a high level language is easier from the perspective of the coder or the developer. So as you can see here, the definition says a high level language allows you to write programs in a human readable format without dealing with hardware details. I would like to tell you that there was an language earlier which was also called as the assembly level language. So in that the developer has to take care, they have to also consider the hardware requirements while writing the program. So it was very hectic to write the code while also making sure that the hardware will be compatible and all these complications. So high level language was introduced, so now the developer can write the code as they want, how much they want, without trying to understand the hardware requirement of the code. So the next point says that using Python, for instance, allows developers to focus on logic rather than hardware complexities like memory management. So as I've told you, the complexities like memory management or the CPU requirements. And the code example is an illustrative example. Let's say print hello world shows simple syntax in action in high level language like Python. So this is a simple print statement. As you can see, the syntax is just print and the text that you want to print. But if you are considering a assembly level language, then you would have to write this in 3 to 4 sentences. So imagine just if you have to write a code about something complex, say like it includes loops, so then it would have become a really really big code even to write and even to understand. Yeah. So I hope now you understand that what is a high level language, and Python is a high level language, so it is easy to understand and you do not have to worry about the hardware requirements. Moving forward, what is an interpreter? So Python is using an interpreter. Okay, so what does interpreter means? That whenever you're writing the code will be executing line by line. So if say you have written a 50 lines of code, so every line will be compiled one line at a time. So it is like one line execution. So in this way, the debugging becomes easier because you will know at which line the error code is, as compared to the other languages like let's say Java or C. So in that cases, the compilation takes place as of the entire code, and after the compilation is completed, you will get the error. So in that way, the debugging also becomes difficult. But Python is an interpreted language, so execution is one line at a time, and so debugging is easier. So point number 2 says illustrative example. The interpreter processes one line of code at a time, enabling immediate execution. So immediately it is executed and immediately you can debug it as well. Iterative nature. The line by line executions allows for interactive coding and testing in Python, right? You're writing the code, you are getting the error, and then you will be testing it out. If there are errors, and then debug it and again execute the code. So it becomes easier. It is an interactive nature. So as you can say, the benefits are easier debugging, faster to test and modify the code. Obviously, if you get the error, you will modify it then and there, so it's faster and ideal for beginners and rapid development. So moving next slide. In this slide, we have like a comparison between a interpreter and a compiler. As I have as I have told you, Python is an interpreted language and Java or C is a compiler language. So let's see the different pointer wise. So execution codes, Python is going to execute line by line, whereas the compiler based languages are going to execute the code entire program at a time. Once you complete the program, then you will execute it, then you will get the errors, then you will again test it, debug it. Now, talking about the speed, the interpreter is slower and compiler is faster. I have explained this to you in the previous video as well, and the reason is same, because it is going to execute one line at a time and then see if there are errors or not. If there are errors, it will pop out the errors immediately. Then you can debug. But in the case of compiler based languages, what is going to happen is, if even if there is an error, they will still continue to the next statement and compile the entire program, and at the end of the program they will give you the errors. So it will be faster, because it will not be interpreting, it will not be stopping the compilation as soon as it finds the error. It will first complete the execution and then give you the errors. So it is faster, but on the other hand interpreter is slower. Now, next point is error reporting. So, as I have told you, single line by line, if it finds the error, it is going to report the error for that particular line. So, error reporting is once at a time, and as compared to the compiler-based languages, it is going to be all at once. After compilation, all the errors inside the code will be shown to you. And now, what where is the interpreter and compiler based languages used for? So, or basically in which domain are they good for? So the interpreter based languages are good for beginners, and whereas for scripting, whereas the compiler based languages are good at large and optimized programs. Moving to the next slide, understanding object oriented programming. So I have already told you that object oriented programming is the very important concept. Actually, Python is an object oriented programming, and everything in Python happens in between objects, class, methods. So you can say that object object oriented programming is the way of writing code that models real world things using objects. So for example, you can say objects can be, it can be a dog, it can be a cat, it can be a car, it can be any object that you can think of as a real life object. Okay, then that object is going to have properties. Let's say dog is, it can be a black dog, it can be a white dog. Say a car can be a red car. So an object is going to have properties. Okay, and then object can perform certain action. For example, a dog can bark, a car can drive, right? If you have a phone can ring. So all this for object oriented programming, what is object, what is a class, what is a method, what is a variable. For this I will be explaining in detail, but just for now, to understand that Python is an object oriented programming language and everything is an object. Okay, again, class creation. Inside the classes there are going to be objects and methods. Okay, so that is like an encapsulation. And for an example, here we have an example of a class is a dog. As I told you, instance of this class can bark, right? There can be an action that can be performed by an object. So here that action by performed by the object dog is barking, and showcasing how methods relate to objects. So methods we will see later on as we proceed further. Structured programming language. Now there is a concept called as structured and unstructured programming language, and Python comes under the category of structured programming language. Now let's see what does this structured programming language means. By definition, structured programming means writing clean, well organized and logical code using control structures like loops, if else and functions, right? So it is easy to understand because it is an organized programming language, and it has structure. There is a structure like loop, if else, function. So you will be able to differentiate a certain chunk of code. If you see a loop, you will be like, okay, so this is the loop. If there's a if else, okay, this is a if else, this is a function. So it is well organized, so it is easily readable as well. So it has a structure, hence it is called as structured programming language. Now what is the importance of control structure? Control structures are essential in structured programming for controlling the flow of execution and ensuring clarity in the complex structure, right? Because you need to understand the flow. When is the code starting? Then where is it flowing next? If there is a loop, then where is the loop starting? Where is the loop ending? Is it pushing me to some other piece of code? So this flow is important to understand, and using this control structures, you will be able to understand the flow. Now, example of a function is the provided Python code demonstrates a straightforward function illustrating how to create modular reusable blocks of code. We will see an example anyways coming forward. Now, I have told you that Python is a portable language. What do you mean by portable? By portable, I mean that the code written in any of the OS can be used or can be compiled on any other OS. For example, if I have my system is a Mac system and I have written my code on my Mac device and I now want to use it on my Windows device, then I can do that because it is a portable language. See, by definition, it says Python code can run on Windows, Mac, and Linux without modification. Example is a simple sprint statement Python script runs unchanged on multiple operating systems. Right. If I'm writing a piece of code on my Mac device, the same piece of code can run on any other OS because it is portable. It is not dependent on OS. Open source. So I've told you Python is open source. What do you mean by open source? Now there's something called as a closed source or restricted and open source. What Whenever a language or an application is restricted, that means it is private. You will have to pay or you will have to request or subscribe. When I say that it is private or it is restricted, that means you will have to pay in order to use that application or that tool. But when it is open source, remember that it is publicly available, publicly accessible. So you can just go use it, download it from their website and use it as per your requirement. Python is free and open source. Python is free to use and its source code is publicly available for anyone. Example of for free download, you can download and use Python at no cost from the official site python.org. Fine. So it is open source. It is freely available. Community support. Python has a wide variety of community support. That means there are a group of Python enthusiasts, developers, Python users who have a group, and whenever they have any question, they will go to that site or ask questions. And if the question is already been answered previously, then they will go and search for that question in the FAQs and get help from that community support website. Okay. There are also helpful online platforms like Stack Overflow, GitHub, Python, Discord. So developers usually go visit this site and get answers from there. So standard library in Python, this is also an important concept. So see, Python includes a built-in standard library which provides a multitude of modules and functions for common building stacks. One simple example I will like to give you is if you are using C or Java and if you want to do a very simple function called as adding of two numbers. So what you will do, you will define two variables, assign them some value, and then define another third variable, put some a plus b, then you will perform addition a plus b and then print that addition. But in Python you have a standard library in which all these functions that are mostly used are already available pre-built, that is built in. You will have dot sum, which is the function that you can use. So most of the time that was used in writing these functions will be eliminated because these built-in functions are already available in the Python standard library. Easy implementation. An example shows how to use the math module to calculate the square root without any additional installations. So even if you have to calculate the square root, you will have to write the entire formula. But here you will have that already built in using the math module. We will see that going forward when we start with the coding part. But you just need to understand that when you use Python, there are already built-in libraries and you will not have to write complex codes, at least for maths and stats, because Python has a rich set of library. No installation is required since the standard library comes pre-installed, right? So you will not have to install it again. It will, once you install Python, all these built-in libraries will be installed within the Python itself. Cross language integration. So yeah, this is also one of the key features of Python. So Python can interact with code written in other languages like C, CPP or Java. Utilize libraries of C types or C, you don't need this. And then examples of interfacing with C libraries demonstrate practical implementation. Suppose you are working on a project in your office or in your college or something, and your colleague is working on a code in C and you are working on a code in Python. Now you want to interface it, integrate it, merge it, so that can be done. Okay, so because it has a cross language integration functionality. So yes, these were some of the important concepts that I wanted to talk about in Python, because I know some people might be already knowing this, some might not be knowing this. although these questions will not be asked in the interviews, be assured about that, because these are very basic things. But in order to learn Python, you should always start from basic. You should understand every concept and only then dig deep. So I have covered this also, and soon I will be covering even more theoretical concepts, and then we will move to hands-on practical labs. So I hope you have liked this video and found it helpful. Stay tuned with my this series. I'm going to do a complete Python series which will help you from from learning Python from scratch to be able to build your projects single-handedly at an individual level and publish it on your GitHub or any other platform. So yeah, stay tuned and bye. Take care. I'll see you in my next video.